Thank you so much. Thanks you guys for having us. And thanks for spending your evening with us. If you can't tell, I'm from the US, and we came all the way here to see you guys. So we actually have a picture. We've been spending time this last week with Tasena and all of the folks, and they've had us here to talk about what we're doing around AI and machine learning. Jeremy is not from the US, he's from Germany. So he gets mistaken all the time because he hangs out with all these American AI people, that he is an American, but he's actually from Germany and he lives in Germany. He just volunteers to hang out with us. Jeremy has his PhD in AI, and we work with him as well as Jason Arbon, who wrote How Google Tests Software. So at PinkLion, we work with some of the smartest folks in this space and want to give you guys some of the stuff we're seeing around this and get your take on it. So, Jeremy, anything else we want to add about you?
I'm good. Thank you.
So I'm the CEO of PinkLion. Jeremy is the CEO of Retest. So you have the two of us here who are trying to lead this next generation of tech responsibly in the world and bring AI to the world's teams. We'll show you a quick little video on PinkLion and some of the companies we're working with, just so you get something. It's more just to wake you up because you've just had snacks and it's late at night. So we'll see if you like this. I think Marcel has seen this enough that he'll probably hear this song in his sleep for the next month. All right, here we go. All right, so we have AI that's working right now in a lot of different industries, as you saw. It is the only thing currently that works on gaming engines. So anything based on Unity, Unreal, or custom gaming engines. And we'll show you that a little bit later. But the primary purpose of tonight is to talk to you guys about what does AI look like in testing right now, what's real, what's not, what's actually working out there today, so you know. Where you can use it, and then Jeremy will talk a little bit about some of the different approaches, because as with anything when it's new in the market, people have different ideas about how best to apply it. So we're going to talk about two different strategies tonight about using either the DOM, as Marcel mentioned, or not using the DOM, and the code layer. So two different ways to look at it, and that's really personal preference on the problem you're trying to solve. At PinkLion, we work with both, which is why we're really good friends with Jeremy, and we're really good friends with Test.AI. Everyone approaches this a little bit different, and we're all about picking the right thing that fits and then layering that into the organizations. We want to make this conversational, so we hope that you ask us questions. It's always better when we get information from you on things you want to know about it, but we'll give you some information, then we'll ask you guys to tell us some stuff about what you know about it already today, so we get your perspective. What we do know about AI and software from industry experts, not just ourselves, and what they're saying out there in the market space right now, is that the quote used to be, software is eating the world. What they're now saying is AI is going to then eat software. So we need to get some understanding of it as we see how the world is shifting and changing. We have a lot of changes already with chatbots, other things that we engage with. Companies don't always tell you that you're engaging with their AI, but you are every day. If you engage with different companies, fast food organizations, Uber, Lyft, any of the big organizations, you're using artificial intelligence solutions that they're working on. But this gentleman happens to be the CEO of NVIDIA, and he's saying, in the future, this is coming. This is where the world's going. And then we look at what Gartner says as well around statistics about what are the game changers that we are seeing in the space. And two things really stand out in the last survey that they did, layering into what Marcel already said earlier, but artificial intelligence is one of the biggest things companies think will change how they do business. The second thing is data analytics. And the reason those two go hand in hand is once you have AI and artificial intelligence, what comes with that is a large and vast amount of data. And with that data, you get insight and information. So a lot of testers, Jeremy and I go all over the world and talk at conferences all the time, and I think one of the biggest misconceptions or misperceptions that I see in the world today is people in the testing space that are resisting this because they think it will take their jobs. And the reality is it actually helps us do work better in this space. I think of AI as my virtual research assistant. It can go out and gather vast amounts of information and data on things that I don't want to have to do repeatedly, on those low-level rote tasks that I'm doing, and bring back synthesized data that is clustered and analyzed around what the core problems are that I then can use to make recommendations to business users, product owners, developers, other folks in my organization to drive better product development and speed things up. So what we do know is there's a lot of other stuff people think about, but the key ones are AI and machine learning. Now, for the folks in this room, I'm going to ask you a question because it helps Jeremy and I focus what level we're talking about. So for those of you in the room, I'm going to ask how many of you have no knowledge of AI and machine learning, how many of you have a little bit of information, and how many of you know lots of stuff about it, because that helps us gauge what level to talk about tonight. So how many of you would say, I don't know anything about this, teach me the things? Okay, you guys are shy tonight. How many of you have some information on AI? Okay, that's more of you. Good. Okay, a little bit, we know a little bit. How many of you are experts in AI? Perfect. Jeremy, find these humans because we're going to talk to them afterwards. So we're finding you. Jeremy has just cataloged all of you with his AI that automatically tracks all of you. So there are a couple experts, and we appreciate any feedback you give us too and your insights, because there are not that many experts in this space right now. So for those of you that don't know a lot or that want a little bit more, you hear these two terms interchanged, and I always like to give it in a visual so it sticks in your head later on about how this works. Artificial intelligence is the bigger picture of everything out there that you hear about. So this is what's in movies. This is what they call narrow and general. These are the nanobots that they've talked about for years and decades that are going to take over the world. That's artificial intelligence. It's any intelligence that's not human-based, that is based off of computers. Machine learning is actually the algorithms and the information behind it. Thanks, Marcel. We see you up here. So machine learning is the stuff that's on the inside that runs the algorithms. It's really a lot of math, right? So it's a lot of math that's based on. So what we'll talk about tonight in testing is a lot of that math, and how does that math actually work? One of the things that we're seeing, Jason Arbon, myself, others in the space, are calling postmodern testing movement. So if you Google postmodern testing, what we are talking about is the shift from the traditional test pyramid that all of us have used for years to what we're calling the testing cake. And that fundamental shift in the work that we're all going to perform as testers as AI takes over more and more of that top layer of that pyramid's work. So when we think about that top layer, that is the traditional UI tests that were hard to maintain, hard to make sure that we were able to write tests against in our mobile apps and our websites, because it changed frequently. So your traditional automation using Selenium and Appium was brittle, you were constantly maintaining it, it didn't work well. But now what we have using AI is the capability to leverage that piece of the testing in a very effective way. Now you'll see AI start to move down that pyramid into other areas. There are some companies that focus solely on unit tests, for example, but what we do know today is a really good use case for us is the top layer of the pyramid. So that would be the things that were traditionally UI based. BVTs is a term that we standardized on with IBM and some other companies. They're business verification tests that every time you pull them into your environment, you're able to run a BVT or business verification test and see what changed, what the differences were in the deltas. Now this automation, we'll talk about two different types. One relies and looks at the DOM, one does not. The type that does not look at the DOM is able to actually run those scenarios without writing new code, because it's looking at it visually the way you and I would look at it as a human. So it's a fundamental different approach in how we look at it. The next thing we can do after we have those is start to write custom scripts that integrate. I'll show you some examples of big companies. So we work right now with gaming companies, so a little game called Fortnite, some people may have heard of that one in the world. League of Legends, some others as well out there in the gaming space. Uber, we work with them right now on some things. A search engine called Google that some of you may or may not use during your lives, they are using some of this technology as well. So lots of big companies that are looking at how do we leverage this instead of this in our organizations and plan for it proactively. So that's what we're looking at tonight. The reason we do it, so there's actually a strategy behind this of why this is a thing. So what we know is covering all the things is hard, and we sometimes miss stuff. Not because we normally wouldn't, but because we can't check all the things all the time, continually. So what you see here is an app. This may look familiar, so this is Amazon. We are able to run without hooking into their code, Amazon, and check different things on their site. This is actually not a $75 rat, right? If you can see that, it looks like that rat's $74.28. That's a very specific price for him. But what it actually is a bottle of Gucci perfume. Someone went into Amazon's site, replaced the normal picture of the Gucci perfume, which you see several other bottles of Gucci perfume at the bottom. They replaced them with this rat image, both on the bottom as well as at the top. And it was very strategic in that if you click forward in each of those images, you get the front image of the rat, the side image of the rat, and then the back of the rat, right? So you get all views of this rat when you clicked on it. When we first showed this to Amazon, they were in an event with us. They had looked at it, so they went on the site, they checked it, and they said, wow, that's still there. And they said, how long ago did you find this? It was about 3 weeks earlier that we actually had caught it. Because think about, with hundreds of thousands of products, how often can you check every single product on your page? Within under 20 seconds, Amazon was able to remove that product once they knew about it, but they didn't know about it. There's a lot of those things that occur in our lives as testers. And this is just to demonstrate the fundamental problem we see today for all of us as testers in doing what we do, which is the level of complexity of technology is increasing significantly at a rapid rate, while we're all being squished down of how much time we can spend to test those things. So as the complexity increases, our time is shrinking, and that creates this coverage gap of what are we going to be able to test. And so we have to look at more efficient strategies of how to do that work. And this is the fundamental reason why folks like Jeremy and others got into this business, to solve that problem for all of us that have to test, and we want to fix this. So the idea and concept is there's very few of us that should go home at night every night going, wow, I don't have anything to do. I'm so bored, right? And if you are, Jeremy and I are looking, so come find us. We will help you not be bored every day. If that's a problem, let us know. But this is the fundamental problem everyone's trying to fix. The other thing we know, again, using Gartner, all of the people, intelligent automation is the way that people are shifting, transitioning, and moving. And this is something that we need to be ready for. What I always caution people about is if you don't get a strategy on this, executives and C-levels who go to conferences, talk to people about what are you going to do about AI, what are you going to do about machine learning in your technology teams, they're thinking about it, and then they give us strategies. What I think is better is when all of us as practitioners and people in the space get informed and educated and proactively have a stance on how do we address this challenge for us as testers, because we do the work every day. So how does it play, where does it play, and what makes sense? And then proactively building that strategy. So I think education is the best piece for all of us right now, of just gaining more understanding in this space. And then Jeremy will talk about more about how you actually get more understanding of one of the approaches we're using in this area.
Right.
Sound fair?
Thank you very much.
Yeah.
So, who of you considers himself a professional tester? Please raise your hands. Okay, keep them open. Keep them up. Who of you has ever tested software at least once in his life? Yeah, please keep them up. Who of you has ever spotted a bug? At least once. Okay, and who is using Windows? So we now established that everyone somewhat knows about testing, right? Do you hear me? Is that the audio working? Yeah, okay. So that every one of you knows at least something about testing. And so if I give you a new software that you have never seen before and would ask you, is that value correct or not, what would you say? Like I showed you a value, it says like 560, and you have to say, is it right or not? What do you say?
I'll have to test it.
You have to test it, right? And you have to understand what the software is actually doing, right? So if you give it, and AI frankly is in the same situation. So if you give AI a brand new software that it's never seen before, and it tries to test it, it has to decide, is this value right or not? And this is called the Oracle problem. And the Oracle problem is a pretty fancy name for such a trivial problem, right? For many software it's trivial to say this is a bug or not. The reason we call this the Oracle problem is if I could come up with a perfect Oracle that for every given software could determine whether it's correct or not for any given input, then I could give it an input like that. I could write a 3-line software that always returns no and ask it, does God exist? And in order to, and it would return no, obviously, because, it would return no to everything. But in order to determine whether the answer is correct or not, it would have to know whether God exists. So any given problem on Earth can be turned into the Oracle problem, which means that any tester is working on the most difficult problem of humanity. Because if you can solve the Oracle problem once and for all, you can solve any problem once and for all, because you can turn any problem into the Oracle problem, right? So the Oracle problem is a pretty big thing, and this is something that most developers don't get. Like if you ask a developer, for a developer, the world usually looks like that. So here's all the complexity hidden in the software. Like whatever software you have, if you have, say, a tax calculation software, then the complexity of calculating the tax is hidden inside the software. It's hidden in the algorithms. Like you have a user, he doesn't need to do his tax calculation. That's the whole point of having the software, right? So he has a simple, intuitive, easy to use user interface, right? And the tester is most of the time working on the same, so the purpose of software, you could say, is to make your life easier. I mean, there are many different purposes. One is generating revenue, but from a user's perspective, the reason you use software is making your life easier, right? That's the reason you use software. And so if you have like a problem like that one, where you want to log into a software, say into an account, right? The complexity of that is hidden. So you don't have to deal with how to identify user. You don't have to deal with biometrics, with cryptography, with all of that stuff that's hidden behind the software. You just give it username and password, and it logs you into the system. And this means that from a developer's perspective, all of the complexity, like the GUI, the layout, the data persistence, all of that is hidden behind the software layer, and all the user has to deal with is to identify components that he wants to interact with, like an input field, a button, stuff like that, and to deliver some simple actions and simple data in order to interact with the software. And from then this means the tester has the same perspective, right? The tester doesn't get to deal with all of that complexity usually. He only interacts with the software from the outside, meaning that he has it easy. And this is the way that many developers treat testers. They say, okay, testing is easy. Everybody can do it, right? Because, you're dealing with a user interface which is simple, intuitive, and easy to use, so everybody can test, right? So that's the perspective of the developer, usually. But the reason why that is not true is if you are a tester of, say, a text program, it doesn't suffice to just use the text program. You have to understand it in order to verify that what it returns is correct. So a user doesn't have to do the text calculation. The user just uses the text program, and the algorithm returns, hopefully, the correct results. But the tester can't trust the results the tester has to verify, right? So he has to do the text calculation himself, manually, or whatever he uses, in order to verify that what the software returns is actually the correct result. Meaning that you have some, at some point you have some solution knowledge, maybe you know the algorithm of how to calculate the correct text, and then you have the developer who formalizes that knowledge into code, and then in order to verify that the code is correct and correctly encodifies the solution, the tester has to test the code and has to understand the complexity of the software. So whatever you test, the tester has to understand. And this is actually one of the main things a tester has to do. Like this is from Ministry of Testing, all of the tasks that a usual tester has to do throughout his day, right? These are like a bunch of tasks. And the most important thing is understanding the user. Like if the user doesn't like the software, doesn't like the user experience, doesn't get the job done using your software, then that's a problem. Actually, that's in the last Gartner report.
I was just going to say that, the last Gartner report. So do any of you read the World Quality Report? Do you know what the World Quality Report is? Okay. For those of you that don't, write it down. It's called the World Quality Report. It's produced every 2 years. They survey across the globe and ask people questions. And this last year, for the first time, to Jeremy's point, I mean, this is why this is such a big deal with AI. The previous answer for why do quality teams and quality exist in organizations, the answer was to find defects and software issues prior to release. The new answer is end user satisfaction, to your point. I mean, this is what you need to be worried about. Right. This is why they say we all exist now, right? And that number is trending upwards in each report that we see now, with it for the first time taking over this last time.
Right. And so one could argue that the main purpose of a tester is understanding users' needs. Mm-hmm. And even if you're a very good tester, if you're like not only verifying the given requirements, but if you use your brain and want to go deeper, then you can not only verify the solution that you got, but you can verify the plan. You can verify the domain knowledge. You can even verify that we're solving the right problem. Like you can say, okay, I want to share images, and you can either implement Snapchat or you can implement Instagram, right? It's addressing the same problem. So the question is, there's a problem, a user need, and how do I address it, right? And there's just, many different ways of addressing the same problem. So the user has, the tester, if he's a very good tester, can influence how the software addresses the user's needs or the user's problem, right? And now, this is actually one of the only points I disagree with Jason. It's funny that Marcel was mentioning that earlier as the fifth point.
Well, we both disagree with him on this. So what you'll find is in this space, everyone has a little bit of their take on everything, right? So Jeremy and I don't believe we kill all the humans, right? At the end of the day, that's the difference, right?
So the question is, if this is really what the tester is doing, well, how are you going to replace, how are you, no, that was too fast. There. How are you going to replace the tester with AI, right? So in order to have AI test your software properly, like through all the layers, it really has to understand what the software is doing, right? Mm-hmm. And it has to understand the domain knowledge, the problem domain, has to understand the problem, has to understand the solution, and analyze the complexity through all the layers. And yeah, we think that this, maybe we'll get there some point, but
it'll take a while.
It'll take a while. And coming back to the previous slide where we said logging into a system from a user's perspective is an easy task. You have to provide it with username, password. That's it. So for a user, it's easy to log in. From a developer's perspective, you have to have cryptographic algorithms, you have to have like load balancing, you have to have like, a lot of stuff going on in the background that the user doesn't see and doesn't care about. But in order for the AI to verify whether the solution you provide, your login page, is working correctly, it has to understand the domain knowledge, the problem domain, because otherwise that looks pretty much okay. Like, log on and you have an error message, that could be, could be okay. But if you read it and if you understand the problem, then telling the user that the password is taken by another user and actually giving the username of another user is not a good thing when you want to log into a system, right? But the AI might not understand that. Actually, you can, if you want to, you can simplify that, and maybe you want to go back. Maybe you say, okay, we want to do that in, say, 10 years. Now we want to go for the simplest task. Simplest task is verifying that the solution someone implemented is actually correct according to the solution knowledge. Like someone specified what he wanted, and the developer went and implemented it, and now we want to verify whether the implementation is correct in terms of the requirements. So you don't want to go all the way up, just the last step. And then the question is, so then what you still have to communicate, or the AI still has to understand the solution. So it has to understand what the requirements are, right? You deliver it, the requirements in some form, however, prose text or whatever, and the AI has to understand it in order to verify that the formalization is correct in terms of the intended solution. But if you can do that, if you can analyze the solution, the intended solution, if you can analyze the requirements to that extent that you can verify that the solution, the given solution, actually satisfies those requirements, then why don't you just generate the solution, right? So if AI masters the complexity of the problem, why not have it create software in the first place, right? Error-free. And error-free, by that I mean error-free, or we mean in terms of the given solution, in terms of its understanding of what you wrote. So it's not error-free, it's not bug-free, but it's bug-free in the sense of, this is what I want, you return it, this is exactly what you said you wanted. It's not what you really wanted, but you said that you wanted it, right? So it's error-free in terms of the given requirements. And actually we have that already. We have that already today, even without AI. It's called a compiler. So give it text, and it turns that text into software, right? It's just that the text has to have a very specific, form. It has to fulfill very specific requirements itself, but this is actually what we have today. So if you encounter a bug in your software, would you go, oh, probably the source code is wrong, or would you go, oh, probably the compiler is wrong? Right? Who's for the compiler? So you probably go for the source code, and this is what I'm talking about, right? This is just the next level. You don't have to give the AI source code or specific, formalized way of describing the software that you want. You give it just prose text, and the AI will transfer that into actual software. Which means that if you have AI that formalizes the code error-free in terms of the given requirements, then you still have to test it. You still have to verify that it's correct in terms of what you gave it. As I said before, this, someone says, this is what I want, the AI generates what you said you wanted, and then you have to go and check that it's actually what you wanted, right? Because this is usually the problem. Who has users who said, I want this, and then you give it to them, and then they say, oh no, this is not what I wanted. Who has ever encountered that? Right? So this is the reason we need to test, even if we have AI. Because you still have the circle, you still have like the iteration. This is, Agile at its core, right? You define what you want, you skip the development phase, you just generate it, and then someone has to test it and say, okay, this is really what I wanted. And actually it turns out there are approaches that even try to do that today. So there's, for instance, Catch the Code, which is it's open source. You can go and find it. But there are other approaches as well. And what this does is you give it you sketch what you want. You sketch the user interface, and it generates the code that is this user interface. So it generates HTML that looks like the paper that you gave it. or the scan of the paper that you gave it. This is actually already today it's working. Obviously, this is the first step, so it's a long way to go to generate all of the software, but it shows that it's possible in principle. And other companies are already going there. Like for instance, Facebook, they already generate bug fixes, which is another way of generating code, right? They have an internal software that's called Sapiens, and Sapiens is 24 hours, 7 hours a day, testing their apps, like internally. You can't buy that. Using AI, and when they spot a bug, like a technical bug, like a null pointer exception, any like error index out of bounds exception, anything that is technical, that you don't need a user feedback for it's a bug. So as soon as the AI encounters that, it can automatically come up with a fix. And the idea is you change the least amount of software, so everything else should stay the same, except for the exception should be gone, right? And if you can do that, if you can come up with a fix that doesn't change anything else, but makes the exception go away, makes the technical bug go away, then you can say, look, I found a fix. And they have that internally. So if you're a developer at Facebook, you get your software fixed automatically in specific situations.
Okay, so let me ask this question then. Do we think that testers' jobs go away first with AI or someone else?
So I would argue that the first jobs to go away are the developers' jobs.
Yeah, okay. Just thought I would ask. Thank you.
Actually, it's not that bad as it sounds. Like, I mean, you all being developers, you don't need to be frightened, right? Because I don't know if you know, but just recently, like when you asked a mother what she would want her son or her daughter to be, 20 years ago, she said a doctor, because a medical doctor. Like he would earn a lot and have a secure job. If you ask them today, they say developer, because developer has become the #1 job. Even better than a medical doctor.
Well, basic code fix developer jobs. You have to do higher order developer jobs. There's still lots of work.
Yeah, right. And this is why we need this, actually. We have
it's required.
We have a demand that we can't address with the developers out there.
Right.
So we need that in order to address the demand of the future.
So if you like doing bug fixes, that may go away from a coding perspective.
Coming back to AI, one of the things that you need to know if you're using AI is that it's biased. So it learns from the past, even some might argue perfectly so. It learns what you give it in terms of data, but what it learns may not be what you want it to learn. Like this is an example of a teacher that it was, I think, 2016, I think, or 17.
Yeah, on the East Coast in the US.
Right.
Yep.
And she, so she was recognized by her, by the, who's the guy who's running
the principal.
School? The principal, thank you.
The principal.
So the principal of the school named her a very good teacher for dealing with all the difficult classes and all the difficult kids. And 3 months later, she was fired by the system. Because you might not know this, but in the US, they have a system where the bottom 2% or 5%, I don't know exact number, of teachers, the lowest performing teachers are automatically fired. And she was fired because she was dealing with all the most difficult classes, the most difficult pupils, and therefore she was rated very low by the system. Like the system said, okay, she has all the bad classes, she has all the bad pupils, she has to be bad, let's fire her. That's what the AI came up with. And the reason it made it to the news is only because she was named such a good teacher like 3 months before. So, but this is actually happening today. AI is coming. It's coming for your jobs even, if you're a teacher. Another example from the US is that the justice system, there are so many cases and so many things happening that the judges are overwhelmed by the cases. So in order to help all of the judges dealing with all of those cases, they employed an AI system that would give a recommendation. So it's, I mean, the judge can overrule it. It's just a recommendation. But, you know, going through thousands of cases of the past, it will say, okay, for instance, in that case, Vernon Prater was a legal offender, and the system rated him low risk of being doing it again, right? And Britta Borden was also a legal offender, and by the system she was rated high risk of, you know, committing another crime within a certain amount of time. So the judge ruled him to go by a low
Probation.
Yes, right. Thank you. And she was not. She was taken to prison.
And she was a mom who took a scooter on a first offense, or a bike. Sorry, she stole the bike.
Right.
She stole the bike to be able to go get her child. Right? But she is an African American female who lived in a particularly rough neighborhood. So based on her background ethnically, her geography of where she lived, and historical patterns of women of that same demographic, she was rated a higher profile offender than the gentleman, even though what he did was much higher risk, but he's a Caucasian male who lived in a nice neighborhood and theoretically shouldn't have done what he did. So that's the problem, right? There's inherent bias in this stuff.
Right. So what we want to say with that is AI is coming. It really is. Like, this is not future stuff that at some point maybe might happen. This has been 2017 also. So this is stuff of the past. This is already happening, whether you know it or not. It's the reality. AI is coming. And, you know, things are changing very fast. Like in 1997, like my mom taught me to not get into strangers' cars and don't meet people from the internet. Today, we literally summon strangers from the internet to get into their cars, right? Like 20 years later. So, you know, things are changing, and they are changing fast.
Yeah, huge paradigm shift.
Another example, I was taught to not sit too close to the TV because it's bad for the eyes. Well, 20 years later, you couldn't get any closer, right?
Totally.
And what is the one thing that is problematic about that is that it teaches you at some point to stop thinking. Like the judge, the example with the judge, he could have overruled what the AI was proposing, but because, you know, he has like, I don't know, 20 cases a day, it's very easy to just go with a suggestion and just do what the system tells you to. And this is happening for a lot of cases for us. Like many people today, they get to meet their spouse via an app. Did it ever occur to you that if the app tells you that it's a match, there's an AI algorithm behind it, analyzing you and analyzing, you know, the other part, and telling you that it's a match. And it's not even in your own best interest, because most of those companies have a monthly fee. So the longer you keep looking for your best match, the more money they make. So they're not even interested in showing you the actual best match. They're interested in showing you someone who's close enough to keep you hooked, but not quite right, so you keep looking, right? And also with jobs, it's the same. Like LinkedIn jobs, and even as an employer, you have the same. Like Amazon filtering through all the applications using AI, it happens on both sides, right? The people looking for a job use AI to find their best job, and the employees use AI to filter out bad applicants. And it happens on both sides. So think about you know, going to the wrong school, having the wrong name, living in the wrong neighborhood. Instead of having a long probation or, you know, going to jail directly, you get the worst job because you're using those systems, using AI, using from the past biased systems, right? This is happening today. And this is actually a funny example of my village. So if you go to the pharmacy and want to get a drug or medicine, It used to be that someone is going, into the back of the store and would retrieve it for you. Today, in my little village, and it's a very small village, they have this robot taking care of that. So you just, you scan what you want, the robot goes and retrieves it for you. But if there's like a power outage or something, the guy working there doesn't have a chance, because there are literally tens of thousands of medicines, and there's no specific order in which they are stored. So you can't simply go in there and try to find it. If there's a power outage or the system has a breakdown or something, you won't get your medicine.
Well, that's a big problem. Like in general, if you think about how much of our world's getting automated, so both Jeremy and I are big believers, I think, in the fact that AI does very specific things, but we always have to manually remember how to revert back and have a backup plan. That's one of the things that testers are good at, is what is our backup strategy if this fails? Because if it does, you have to have another way to revert back. Major issues are happening, to Jeremy's point. If this broke, how do you get drugs out to people that need them in that pharmacy, because people don't remember how to do it manually? It's bigger than that. It's our medical record systems, it's other things that are pretty important to our lives. In the US, they actually had one of the filtration plants that runs the water filtration system for several cities. It was a child, he was less than 16 years old, that hacked into that water tower in that city and reversed the water system. So he hacked into the computer system, reversed it, so instead of clean water out, it was dirty water out, right? So they sent dirty water back out to the entire city. Now, because no one remembered how to manually revert all the processes that they needed, and they didn't have all of those documented appropriately, it took them over a month to figure this out and get it fixed. So as we move forward with all of this automation, all of the AI, the technology, it's important as testers to remember, don't stop thinking. That's what we're really good at as humans, is to remember, how do we think and critically analyze and process.
Right, don't give that up. As testers and developers, it's your job to guard humanity from that kind of stuff, right? And now this is the part which is a little, if you're if you're creating a web application, we created an open source product that you can use to double check your web application. The idea is basically you create a copy of the web application or the website and then compare against that website. And this allows you to find differences and to pinpoint changes, saying that if version 1 worked like that and you manually test the software in version 1, then you generate a test using AI, and I'll come to that in a second, and then you will be giving all the differences, and you manually have to verify whether it's an intended change or not. But this is open source. You can check it out. It will actually, it even gives you unbreakable tests and auto healing. So it enables you to automatically update your tests and not make them break when the ID changes or something. So you might probably want to go there. But the reason we created that is to circumvent the Oracle problem. So remember the Oracle problem that I was talking about earlier? This allows you to do the full circle. Like you test manually, and after you test it manually and verify that it's what you want, then this makes sure it doesn't change unintended, and doesn't have unintended side effect. So any change you introduce will be pinpointed by that. And it's a basis for that. So what we do at Retest, and again, we have different approaches that complement each other. At this point is we have an artificial neural network that we trained with how a typical user uses a typical software. The problem with neural networks typically is they need thousands of examples. And for a small project, this is prohibitive. You can't have thousands of examples if you have 50 users. So what we did is we created this not for a specific software, but for any software. So it learns what we learned in turn. After we did this, we learned that it incorporates UI UX design principles. So it learned, for instance, to press a bigger button rather than a smaller one, or if there's a form, then to fill the form in a specific order, how a human would use the software. And in order to have it specified or specific for your specific software is a genetic algorithm with the benefit that you need one example or 5 or 10 or maybe 50 depending on the size of your project, but very few. And think of it like that. If you are if you have a tester onboarding on your project, whatever you teach him, whatever you tell him, like use this credit card number, use this account, use this item, test item, whatever, this is what you would teach the AI. And it's very few things, typically in a typical project. And then it learns how to generate tests. And then it can circumvent the Oracle problem by, so the user tests the software once, makes sure that this is what he actually wanted, like that it's fulfilling the requirements in their intended way, and then the AI generates tests for that, and then if you change it afterwards, it will make sure that there's no unintended side effect, that you didn't break the software. This is what regression tests are mainly for, right? You have a functionality that is already good enough, and you want to make sure it doesn't break with whatever you change. So this is how we approach that, and this is how we circumvent the Oracle problem.
So the other way to do this, so as Jeremy said, there's 2 different strategies. The other way is we look at traditional automation today and what we do, where you hook into the DOM and you write code against it. So this is an app that all of you will understand and know. So this is something, when I click it here, you've probably seen Uber. The challenge Uber has, so again, 2 different issues. Uber has a different problem than some companies, and you have to understand which problems you have to understand which solution for AI to use. What Uber does, if I were to look at your app and your app and your app right now, in production they're running A/B pilot testing. So you may have things in a different order on the screen than you do on purpose because they want to understand which one is working better for the consumer. Traditional automation would break on that because it's looking for expected things in certain areas on that screen. AI with Uber is really good because what they're able to do is not hook into the DOM and the code. You can move that scooter icon anywhere around on this screen and it's going to be able to identify it. The reason that is we use something called element recognition. So all of you, if you look at these, would know those are shopping carts. To Jeremy's point, what we do is we train it on thousands and thousands and tens of thousands of shopping carts, so it knows every time it sees that equals a shopping cart. Then I can write tests against the elements that I understand and recognize like you and I would view the screen. So here's how it works. We use something called reinforcement learning. This is one of the strategies with artificial intelligence. So once I've learned what a home screen is, what a product page is, what a search page is, what a shopping cart is in an account, I can give it scenarios where I say, go to shopping cart. So it starts at the home button, home screen. It'll move because it's never seen it before like you or I. If you didn't know where something was, you'd look around for it. It'll go to the product page, and then it makes its way over here to the shopping cart. What we do with the bot is we say, nice try, but not perfect. We deducted a point because you deviated from the closest path to get to the shopping cart. So you only get 99 points. The next time we run, we ask it to do the same thing and start at home, but it remembers the shopping cart is over here. It went directly there. By getting that better path, we give it 100. We're reinforcing that mechanism of go directly to what I'm telling you to do and I'm training you how to do this. Very similar to how we train as children when we grow up. Things you learn like language, whatever else, you're learning and training. When you do it right, you get a prize. When you don't do it right, you get something deducted. This is the solution that it does. So this is an actual app. Now what you're gonna see when it runs, you can see it highlighting these elements. These are those elements on the screen that it's visually recognizing when it runs against the screen. I don't care if the back end of the system went from Java to Python, because that doesn't matter to me. It's an abstraction layer. What I care about is what I see on the screen and that I can find that element that I'm looking for on that screen. When it runs, it builds what we call an app graph. So that same example you were seeing earlier, these are the various screens with all of these dots. This tells you where everything is on the page, how it connects to the other things in the other pages, and what's changed. So a lot of us sometimes aren't told when there's a code change or an element change or something's shifted. What this does, every time you run the AI against your website or your mobile app, you're seeing what these changes are, app graph over app graph, so you can make informed decisions about where to test, how to test, and what that looks like. So we'll watch a little quick video on how this works now that you guys understand it. Pretty simple. Oh, we have to.
Similar to how you train a puppy. We tell it what we want it to do, and if it doesn't, we give it a reward. So, if we tell the bot to find every place within an app, for example, that has a dog screen, and it goes out and finds the dog screen, we tell the bot, great job. The bot now has this new knowledge, where it can figure out the best way to get to the dog page, no matter where we started within the app. To do this, we use app graphs. These are representations of all the different parts of the app, and how they interact, and how those parts can flow from one to another. Once this is encoded in, the bot learns all the best ways, but also if anything changes in the app, it still can remember all the ways that it got to the dog page in the app before.
Perfect. All right. So here's the idea. You have to figure out what your problem is, then you figure out what you need to use. AI is coming and testing. These are various things. Marcel showed this earlier. There's lots of uses right now for AI in testing, but for all of you, what I encourage you to say is, what don't I have enough time to cover in this layer that addresses some of the things up on this screen? Pick those elements out. This is the powerful data I mentioned. So besides just having artificial intelligence and machine learning, this is an actual example of running across an app that we don't have access to their code. This is just a general APK that you can pull down. It shows you what steps it took, so 2 things you get, screen captures as well as a video. It's telling you the timing on each step. So some of us as testers have seen, we go, the login seems slow, right? But we can't quantify how slow it is from last time we did this. This actually does this for you, because each time it checks login, it's going to give you detailed steps and tell you CPU, utilization, memory, a bunch of other stuff. We're just showing you a couple of them up here. The other thing that I think is really the big game changer for all of us is not only can I automate my stuff, but if I have competitors, we ran these 3 competitors on their production apps in under an hour. Because when I have an AI framework that works on my stuff, it now works on other stuff as well, because it recognizes those elements the same way as it recognizes elements on my page. We saw that one of these companies, I won't tell you which one because you're testers and you're going to guess, was having cart abandonment issues. And when you look at just this data alone and then we drilled in, it was pretty apparent what their problem was and how to fix that. So this is going to give you very powerful data and statistics to help put you in the driver's seat to talk to product owners, product managers about how do we make better decisions. So I would argue with AI embedded in the quality organizations and teams that are focused on quality, you are now helping drive better products out to market for your users, which is the main goal. This is an app Marcel asked us to run. It's one locally here. We ran it just to prove. I don't have access to Alza's code, but I could run Alza, I could run a couple of other ones. This was, again, in just a matter of a couple of crawls to be able to get through the app. We can tell it navigate now, do a bunch of scenarios, and run it. So again, optimizing what you're doing as a human in that space. The other cool part, this does work on games. I mentioned it. I just wanted to prove that it does. It's the only thing in the world that can automate on games. So if any of you are around coming up, I think Joe Dell will tell me when it is, but our Game Quality Summit is in end of June, early July, but I hear that's when you all go on vacation. But if you're around the end of June, it's in Amsterdam, and we'll be talking with all the game companies because this is dramatically changing their lives of how you test games in general. This may be a game that you guys have seen before just to prove it actually works. Games are slower. As you can see, there's lots of elements to recognize on the screen. This is a very different way than anyone's ever done this before in the world. It actually works. If you check out our YouTube channel for PinkLion, we run lots of different apps. If any of you have one you want us to run for you and send you a video of it, we're happy to do that. So just contact us and we'll run a video for you. But basically this just shows you, it actually goes into gameplay at some point as well. We can do that. What we'll leave you with, Jeremy and I, is there's his open source version that you saw. This is also open source. So this is Google's AutoML. So this is a good place if you have people in your organization to point them to see how AI and machine learning works. You basically go to this URL And then inside of that, you drop a screenshot of either a website or a mobile app, right? And then it'll give you the same stats and data I'm talking about. So you have something to play around with to see that it's real, that this stuff is actually working out there. So I'll show you an example of this. This is one of the screen caps we dropped in. What you will see, us as testers like perfection. AI, the first time it runs, gets somewhere around 60% plus of accuracy. There's 4 tabs up there of data just on this one screenshot. So what I would tell you is, again, immense amounts of information to analyze, but you can see how accurate it is on the first run. And even some things that us as humans don't see that it can identify readily. Last piece, because we know you all want to get home. These are some places we would recommend to go. If you're new in this space and you want to learn more, here's a couple of key resources for you to go to grab some information and learn more about AI. Of course, Marcel's around, they're around. We're working with them to help organizations that want to learn more about it. We left some PinkLion stuff back there. It looks like most of it's gone. But if it's not, take some of that before you leave, because we have to fly all the way back home to the US tomorrow, and Jodelle does not want to put it in her suitcase. So please, please take everything. Jeremy and I appreciate that you listened to us tonight. Hopefully you got something out of it. We'll be around if you have questions and want more information. But visit our website or check us out. Marcel, do you need anything?
I have the winner.
Oh, he has a winner. He has a winner. Good thing you stayed. He has a winner. Let's do this.
Maybe do it together?
Yeah.
Whether you can read it.
Oh, uh-oh. I probably won't be able to read
This
it.
is the name.
Okay. Yeah?
Katerina.
Smirnova.
Okay.
Katerina Smirnova.
Is she still here?
Is she here?
Uh-huh.
Yay!
This is the lady who forced me to speak English.
Oh, we like you. I like when you do that to him. Perfect. Congratulations. That's amazing. So you'll get your free ticket. Thanks, Marcel. That was great. That worked out good. Perfect. Congratulations. We'll see you again. All right. That's all we had. Jeremy, anything I missed?
Nope.
Okay. You sure?
Yeah.
Okay. All right. So thanks, everyone, for hanging out with us tonight. We hope it was useful. So.